Students, today we are going to discuss one more important topic in signals and system is inverse jet transform. Last lecture we already discussed how to find the jet transform, properties of the jet transforms, important of ROC. Now we'll see inverse jet transform. Inverse jet transform. The process of finding x of n from its jet transform x of z is called the inverse jet transform and is denoted as follows. So we are going to find x of n from x of z. So now we are going to find x of n. X of n is equal to inverse process 1 by 2 pi say integration of x of z into z power n minus 1 d of z, where c is epsilon of over c, and this is the reason of convergence of that jet transform, that inverse jet transform. So this is nothing but is a process of finding x of n from the jet transform x of z, and this is the formula we are using to find the jet transform, to find the inverse jet transform. Okay, clear? Now we'll see what are the different types of methods available in to find the inverse jet transform. Less formal way are successful and preferable in finding the inverse jet transform. They are: first one is inspection method, and second one is partial fraction expansion method, and third one is power series expansion. Now we'll see what is the inspection method. So inspection method is very simple only. So we know a power n u of n is x of n, that z transform is 1 by 1 minus a into z power minus 1, and where mod of z is greater than z. This is the z transform of this signal. Now for example, I want to find the inverse z transform of the given signal x of z is equal to 1 by 1 minus 1 by 2 z power minus 1. By comparing the first one and this one, what is the difference have you found? So this is instead of a, here 1 by 2 is there. So from that directly we can by inspecting the formula from the given expression, we are going to write it x of inverse jet transform of the given jet transform x of z is x of n is equal to a is nothing but 1 by 2 whole power n into u of n. Correct? So like this we can write it. That is nothing but inspection method. Okay. Now we will take another one more example in inspection method. Minus a power n u of minus n minus 1. This is also same thing, 1 by 1 minus a into z power minus 1, where in this case mod of z is less than mod a. The previous case mod of z is greater than a. Same thing now I am going to see x of z is equal to 1 by 1 minus 1 by 2 z power 1, and they given as a mod of z is less than 1 by 2. So by observing these two equation, we can conclude that inverse jet transform of the given sequence or signal is x of n is equal to minus a is nothing but in this case 1 by 2 whole power n into u of minus n minus 1, because in this case here mod of z is less than, same expression but the mod of z is less than 1 by 2. The previous problem mod of z is greater than 1 by 2 is nothing but u of n itself, but in this already we did in the previous lecture. So we know how to find the jet transform. From that directly we can, by inspecting the given jet transform formula, we are going to write the inverse jet transform of that one. Clear? So from that, this is by this inspection method can be applicable only the one small can be applicable only small expressions and small problems. We can't go the big one, that is nothing but this is nothing but a first order systems. If it is a second order system, it's very difficult to go for inspection mode. So such a type of problems we are going for the another method is nothing but a partial expression method or partial fraction method. This is very important method and very easy. So now I am going to consider x of z. X of z, jet transform of any system is, we can write it as a numerator poles divided by denominator poles. In that we are going to take it out write it in a constant, we can take it out, write it in the form of roots. So same thing in the denominator also, take it a naught and write it in a numerator roots. So this is the form of this one. Now I am going to explain how to apply the partial fraction expansion method to find inverse jet transform of any signal. Let us consider second order system. Already we discussed the inspection method can be applicable only first order system. By seeing first order system, it having a very small expression. By seeing that, we can write it. By inspecting the formula, we can write it directly, inverse Z transform of the given signal. But in case of second order system, it may not be possible. It will be little bit time takes, and we can't do it accurate. So for that case, we are going for the partial fraction expansion method. Let us consider the second order Z transform. X of Z is equal 1 by 1 minus 1 by 4 Z power minus 1, 1 minus 1 by 2 Z power minus 1, and mod of Z is greater than 1 by 2. This is the given problem. We are going to find the inverse Z transform of the given system. So if by using the partial fractions, before going to apply the partial fraction method, we have to first to see the denominator, whether we have the roots or not. So with the in this problem, we have the two roots are there. Sometimes they will give the second order expression itself, that is nothing but a z square plus z plus 1. So in that case, we have to convert that into roots of the equation. So in this problem, we have the two roots. One is 1 by 2 and other one is 1 by 4. So now we can write it as a1 divided by first expression plus b2 divided by a1 or a2. a1 and a2 are the partial fraction coefficient. We can indicate any variable. Here I indicated a1 divided by first root and plus b1 divided by second root. This is the normal formula. Now for finding the a1, we have to find the a1 and a2. We have so many methods are there to find a1 and a2. So we can use any formula to find a1 and a2. Okay, here I used a1 is equal to this denominator into x of z is at z is equal to 1 by 4. We can use anything other formula to find a1 and a2. So a1 I got minus 1 and a2 is equal to 2. Now I am going to replace a and b with the values. A is equal to minus 1 and a1 is equal to minus 1, a2 is equal to 2. Now from this we can directly, here mod of z is greater than 1 by 2. Greater than 1 by 2 is nothing but u of n only. Already in the inspection method we saw, correct? Mod of z is greater than 1 by 2 is nothing, u of n. Mod of z is less than 1 by 2 is nothing, minus u of minus n minus 1. In this case, so first I am writing here positive 2 is constant. So 1 by 1 minus a into z power minus 1. Mod of z is greater than 1 by 2 is nothing but a is 1 by 2 whole power n into u of n, minus 1 by 2 is constant. And then we can write it as this is 1 by 4 whole power n into u of n, correct? This is the inverse Z transform of the given sequence using the partial fraction. This is the simple problem. Now we'll go the different problem, inverse Z transform by partial fraction expression. Sometimes in the previous problem, denominator having the constant, numerator we have the second order. Sometimes denominator and numerator having the same degree, that is nothing but a denominator also order is second order, and the numerator equation also in the second order system. Means in that case we can't go for that method what we used in the previous problem. For that case, we have, before going to apply the partial fraction expression, we have to go for the long division method. So how to go that long division method? So this is the example. This we are considering as both the numerator and denominator degree is same. So we have to divide the numerator and denominator. So write it in a constant plus remaining with the denominator. So that I am going to explain with example. So inverse by partial fraction. So in this example, see denominator. So denominator degree also 2, numerator degree also, so both are equal. So in the previous method we can apply only the numerator roots are less than denominator roots. Denominator roots should be always high, numerator should be less than the otherwise in that case only we are going to apply. If both are equal means we can't go for that method. So first, before going to apply that method, we have to go for long division method. So how to go? Divide it by these two expression. So now I am going to divide these two expression. So x of z is equal to this one. So I divided using the long division method, that is z power minus 2 plus 2 z power minus 1 plus 1 of divided with denominator. This is 1 by 2 z power minus 1, this one. So I'm going to divide it first 2 multiplied with 2, we got 5 power z1. So this expression we can write the constant is 2 plus what is the remaining is minus 1 plus 5 z power minus 1 divided by this denominator. So this denominator already we converted into roots 1 minus 1 by 2 z power minus 1, this one. Now we are going to apply the constant will be as such only. We are going to apply the partial fractions for the second expression. Second expression if you apply means a divided by that a divided by first root and plus b divided by second. Otherwise a1 divided by first root plus a2 divided by second root. We can apply any method to find a1 and a2. Here we got a1 is equal to minus 9 and a2 is equal to 8. Okay. Now I'm going to substitute that a1 and a2 in the given expression. X of z is equal to constant already we got by using the long division method. 2 minus 9 divided by this one. Now I'm going to apply the inverse Z transform. We know constant is nothing but a delta of n. So 2 into delta of inverse Z trans 2 into delta of n minus here 9 into here. Before going to apply the inverse Z transform, we have to see what is the reason of convergence. That is mod of z is greater than 1 is nothing but everything is u of n only. If it is less than only minus u of minus n minus 1. That you should remember before applying the inverse Z transform. Now I am applying directly. What is inverse Z transform? X of z is x of n is equal to 2 into constant is delta of n minus n into 1 by 2. Here a is 1 by 2 whole power n into u of n plus 8 into here we have only 1. So 1 is nothing but a 1 power n. 1 power n is nothing but a 1 only. So u of n. Correct. This is the this is the inverse Z transform of the given signal. Understood? And remaining problems we'll see the next class. Thank you.